Welcome to Practicon. Today, let's discuss about important structural engineering formulas used in structural engineering for design. For steel structures and concrete structures or even composite structures, the predominantly the important and critical stresses normally checked by the structural engineers are pure axial stress, bending stress, and shear stress. These three is comes under the ultimate strength design criteria. So the first one is axial stress. Axial stress consists of compression stress and tension stress. For the members, compression members, further we divide the stresses into pure compression stress or pure axial compression stress and axial buckling stress. The compression force divided by the gross area which provide us for the compression stress and for the compression force divided by the effective area will provide the buckling stress. What is this buckling and effective area? When the member is buckled, some portion of the element will inactive. So within the cross section, the inactive member areas will be deducted and the remaining cross section, the active cross section area will be called as the effective area. Now, come to the tension members. In the tension members, which the stress comes under the yield point, yield stress is nothing but the tensile force divided by the gross area of the section, and the ultimate stress at the failure stress or tear out stress is called as force divided by the net area. So that means the net area, which is actually the, for example, in the steel structures, the member is connected by the welding or maybe the bolted or maybe the riveted. The the connecting part will be taken into consideration to calculate the net area. There are separate videos has been created in detail to understand the net area calculations. So now here yield stress will come force divided by gross area. Ultimate stress comes force divided by the net area. Now, second thing is the bending stress. What is the bending stress? Bending stress is nothing but the moment of inertia which actually leads the bending stress calculations. So the bending stress is nothing but moment divided by the section modulus. Section modulus is nothing but I by y. Y is actually the neutral axis distance from the point of the calculation, and the I is nothing but moment of inertia. M is the bending moment. So when the member is subjected to the bending, the section modulus moment divided by the section modulus will provide the bending stress. There are more calculations added in the different videos. We can review on that. This is a just high level, the important points or important stresses which actually used in the checks in the structural engineering. Now come to the shear stress or stress is actually depends on the shear area. How the shear area will be calculated? The direction of the force acting on the element, for example, in this I section, the highlighted area, web times thickness of the web is nothing but shear area if the load is acting in the direction of the web. So the shear stress is nothing but shear force divided by the shear area. So now in structural engineering, either concrete or steel or any composite structures, the major checks will be performed by the structural engine is axial stress, bending stress and shear stress. Thank you very much. Please subscribe the channel and follow the rest of the videos for more details. Thank you very much.